My name is Ryan Hunt. I'm a developer with Healthcare Service Corporation. Today we're going to be talking about data and about building data environments for production microservices with Geode. This is sort of picking up a thread from an earlier talk in the Geode Summit from some of my cohorts from Anupama Pradhan and Jeff Chern, where they're talking about cloud-native architecture as it pertains to microservices. So this is picking up a thread there that's sort of following the operational side of that thing. So we're going to talk about some of that and talk a little bit first about where we're coming from. This is Healthcare Service Corporation. We stand very close to our purpose, which is to do everything in our power to stand with our members in sickness and health. We are a health insurer, the largest customer-owned health insurer in the United States, and the fourth largest insurer overall. We have about 15 million members and about 21,000 employees. And if you carry a Blue Cross card in Illinois, Montana, New Mexico, Oklahoma, or Texas, there's a chance that you've interacted with us at some point. The company was founded in 1936, which means that it's seen some transformation through technology in its life, for sure. The latest round of that transformation, some of the work is coming through what we're calling the digital portfolio, which is a group of product teams that are creating new digital products and kind of reviving some old ones and rebuilding them when needs be. This cuts across the enterprise, different business areas and portfolios. The products include RESTful APIs, web applications, a native mobile app, and data services. These are cross-functional teams that combine engineering, product, and design. The engineering side employs a lot of the tenets of extreme programming, especially test-driven development and pair programming. So we'll talk a little bit about the APIs specifically. A lot of the APIs that we build, you could call information APIs. And when I say that, I mean that they're not just returning data, but they're responding to queries with a combination of data and business rules. So it's informed by business rules. It's a little opinionated. They're considered the source of truth for their consumers. They are read-only in nature, which can make a difference in the architecture for sure. They're designed in a microservice sort of manner, and there's a focus on performance, because this is read-only, so we want answers quickly. So when we start to talk about microservice architecture, we have a picture similar to this. Now, microservices are billed as being stateless, which is partially true, but if you're going to answer questions with the data has to come from somewhere. So how do you do that? Many enterprises have this idea of a source data lakes, many sources. So if all of your microservices need data, of course you could do something like this, where they all just query the source for what they need and parse it into how they need it and just go forward. The thing about this is that it works. It just doesn't work very well, nor for very long. Just try changing something down in the source data, and you'll quickly find that everything above it also needs to change. You also cannot get the performance that you might want out of something like this. If you have like a generic relational model underneath all of it, you can only optimize that so far. And while all of these services need data, they're all answering different questions, and they all have different access patterns. So you will run into a limit to the efficiency of that. This is a little closer to the picture that we like to see, where this looks more like one of those microservice diagrams, where everything has its own stack all the way down. Single responsibility is a thing. And this kind of cuts down those issues of having to having dependencies in changes. And it means that the internals of each of these services and even their data models can change independently of each other so long as they adhere to some contracts between each other. However, you can see, since we've added more things to the diagram, we now have more databases. And the layer below the databases would be like an ETL process to extract and transform that source data into what the services actually need for their models. So good architecture, but you're definitely taking on some baggage going this way. And that's kind of what we're going to talk about, how to work with that. So as you add more databases, you clearly are going to add some operational challenges to what you have to do. Distributed infrastructure gets complicated. Distributed systems get complicated. Geode in particular and other systems like it tend to be a mix of configuration and code. You can deploy real Java code to it. You can update configurations. All of these things have different sort of nuance to how you do them. As the system grows, and it will, these scale very well horizontally, monitoring and analytics become an interesting challenge. And at the end of the day, building things in these microservice stacks, developers own the whole thing, or those product teams at least own the whole thing. So they've really, you have developers that are taking on day two operations and provisioning and troubleshooting of these relatively complex database systems. And they can be different sizes for different purposes. We have systems that we're running in production that span from 2 cluster members that hold about 600,000 records to 26 cluster members that hold about 70 million records. And we have some in the works that might reach as high as 125 cluster members with billions of records. So how do you kind of keep it together and build all these things? So we've started using a couple of tools, 3 tools. Some of them may be very familiar, others may not. Concourse, Ansible, and Jinja. So I'm going to walk through each of these 3 things with just a little bit of an introduction to them and sort of try to explain why I think they play together well, why these things are friends. I'm going to start with Ansible. Ansible is an automation tool for IT infrastructure. It makes really easy work of doing repetitive tasks to a lot of machines, to a lot of VMs. This is an example of just some of the little blocks of code. Everything's in YAML, which is nice, and it's very readable. It's not too hard to tell what's going on. We can create directories. We can enable services. We can create users. We can move things around, pack and unpack things. It's very nice, and it's pretty simple to use. So this is kind of the base of when we have to do distributed operations that touch a lot of machines. This is the tool that we tend to reach for. Next up is Concourse. This is our favorite CI/CD tool. Pivotal has built it as the continuous thing-doer, which I like because it sort of implies that it's useful in a general way, not just for building code. But if you haven't used Concourse before, this is a little bit of a taste of how it goes together. On the left there, that is sort of what the definition of a job looks like. Jobs have plans and tasks, and those tasks have configurations. And ultimately, this is all setting up something to happen in a container. It's going to build a container, do some things, generate some artifacts, and tear down the container. And then on top of that, you have a very nice web UI that gives a nice dashboard into the state of things. Jinja, I mentioned, might be a bit of the oddball of the 3. Jinja is a templating tool or a library. It's a Python library. It's available as a library or a CLI. Jinja is the templating tool that Ansible actually uses within its playbooks. It's also the tool that's used by the Django content management system to render dynamic HTML. And you can see a simple example of how this goes together. In Jinja, you would have a configuration, a template, and you would put those together to get an output. So in this case, we're iterating over the people and generating a greeting for each of them. This is very simple, but now we see that everything's in YAML and everything's plain text. So we can start to do some interesting things when we put them together. So when we add a little bit of Jinja to a little bit of Concourse, we can start to make a plan with dynamic resources, where these resources could be externalized into a configuration file. And when you need to add one, you add it in one place. And the iterator will take care of setting those up in the right places. There's also some flow control and some more powerful things, where if you're iterating through a bunch of things, you can have flags that change sort of the behavior of what's going on when you generate your output. And another powerful thing is, since these things operate in layers, we're talking about like a Concourse pipeline that's calling a shell script, that's calling an Ansible playbook. You can pass variables and dynamic information all the way down to inform your shell scripts to what they need to do. This ends up becoming pretty powerful and opens the door to reusing a lot of your code. So that's what I wanted to sort of walk through showing. And I'd like to give a little demonstration of a pipeline for Geode that we've created using some of these techniques. So I'm going to leave the show. Okay, that is a Concourse pipeline. You probably can't read much of it, but it zooms very well. Have folks in here used Concourse? Yeah? Cool. All right, great. I was introduced to Concourse as a CI/CD tool for building code, but we've started to adopt it to do other things we need done. So I want to take a look at this. I'm going to actually kick this pipeline off and let it run, and we can take a look at it as it runs and look at some of the things that it's doing. So to do that, I'm going to make a commit. Great. So we should in a second see these guys kick off and start to do that. So the first box over here actually builds our caches, and by build, I mean it installs Geode, it installs the JDK, it installs any other sort of build artifacts that we might need on there. Monitoring or analytics would go in here. We use New Relic for monitoring a lot of this stuff. And if we click on any of these, we can see this is actually executing an Ansible playbook. I'll try to make this big. And we can see as it goes through, we're building and copying files, we're creating users and security groups, and preparing the file system. And then we install Java. Now here you can see these are the resources that came into this job. Right? When these jobs finish, we go over to the next one. And these are set to trigger automatically. And what we can see when we click on this, we can also see the inputs that come in to each one of these jobs. So what we're doing here is we're passing resources through from job to job, and things only move right if they pass. So the things that turn green are combinations of configuration and artifacts that work. So being able to trace back through what combinations went through when is very, very nice. So as we build this, we install the software. The outcome of that first task should be a running cluster. So our next step will be to start that cluster and take a look at what happens afterwards. And we can come down and see that this is another Ansible task because it has to go to each one of the servers and now start the services. And this just takes a moment. Oops. And then you can see our next step over to the right is going to be to test them. So once the services come up, we're actually going to connect to our new running cluster and start to ask it some questions. Mostly, do you have any members? And what are their names? And those need to match exactly what we told it to provision. And while that runs through, I can show what that looks like. So in this case, we're actually using a container loaded up with the gfish command line tool. And we're really connecting to the real cluster, and we're really asking for the members and starting to parse out the responses. We want to make sure that we found the members we were looking for out of all the things that are there. There we go. So if the test passed, then we know our members are up. We can configure it. You don't want to configure members that are not up and running. And in this case, configuration means that we're going to start to create regions. We're going to start to create indexes, disk stores, all of the kind of internal Gemfire configuration that you need to start loading data onto it. And as you can see, these same resources are still passing through here. The reason for that is if you upgrade Java or anything like that, like you don't want, if any of these steps fail following that change, you don't want that change to keep going through. We deploy our libraries to it. So we can see, I want to zoom in on this one a little bit. We have a new resource coming in called the application model. This is very common for the clusters that we have, where we actually load them with the model for serializing objects in and out. So this is a spot where we bring in another resource, and Concourse lets us say that if this resource changes, trigger deploy libs and everything down from there. Not so that we don't have to run through the whole thing every time anything changes. But after those get deployed, we have a rolling restart. Because now, at this point, the cluster is live and could actually be doing some things. We're going to restart the nodes in sequentially so it is up now at this time and it stays up. And as we go through, we then would deploy functions. And at the very end, we test the configuration, which means we check for those regions, we check for those indexes, we check for those functions and make sure that they're all really there. While this is running through, I'm going to jump over to the code for the pipeline and kind of show what this configuration looks like. Is that big enough? Okay, bigger. Tiny bit. Thank you. Thank you, Miles. Cool. So this is what the YAML configuration for Concourse looks like on the left. And this is what the configuration input to the Jinja template looks like on the right. So the idea here is that this pipeline on the left stays fairly static. If you're a team in our group and you need to build a Geode cluster, what's different from one to the next? And that is what we capture on the right. So the idea is that you should be able to provide just the things that are particular to your use case, your application, namely the model, the indexes, what the region should look like, the size of the clusters. And you can feed this through this template and generate a pipeline that will build and deploy what you actually need. So we can see where some of these things come in as we take build resources. We would generate the resources based on that list that's provided. And this is one thing that gets fed right through the templating. So the output of that would look like this, where it generates all of the build resources and the deployment resources, the function resources. So this is really just generating blocks of YAML for us. Where this gets kind of interesting is where we start to loop over larger chunks of code. You see I have a variable here called environments. So the system has built a fully functional cluster on my laptop, which is well and good, but sooner or later you're going to want to move this to bigger and better places. To show kind of the idea of looping over environments, I'm going to do this and add another one. So this is an array of environments with just a couple pieces of information about them. And I'm going to refly this pipeline. Did it finish running? It did. Great. So we can see that this fly is adding kind of a lot of stuff. Let's go look at how that turns out. Whoa. So you can see that our pipeline grew a bit, and it has now kicked off something in the middle. Let's zoom in there. So what this has created is basically two environments. This is sort of the setup you would have for like a lower environment going towards an upper environment, dev to test, or test to prod, or my laptop to dev. And this all is built in serial so that the higher environment only starts to build with the resources that pass all the way through the lower environment. And now you have two perfectly identical environments. If you have more hosts in one or the other, that's fine. That's all addressed in the configuration. But this kind of lets it all flow together. And you'll notice that all the way at the end, we have a version resource. We're doing some semantic versioning. And what this is doing is actually tracking the version of the pipeline scripts themselves. So as we change things, anything that makes it all the way through gets its version incremented. So that makes it easy to sort of track changes back through and keep a good eye on that. So this is starting to build our prod environment right now. Which is great. It's going to go through and make that one just like the first one that we built. While that's going on, there's another case that we've started to come into that beyond just building two environments, a lower and a higher environment, sometimes we come across applications that have data needs that are greater than one cluster. You run into some limitations about the number of members that you can have and the amount of heap space that you can actually put together into one cluster. So to address something like that, you need multiple clusters that all look exactly the same, which is not too different from what we just did, except for some of the dependencies and the flow of things. So I've made, in the templating, a value called serial, which had been true. I'm going to make it false and fly the pipeline again. And now we have two clusters that build completely in parallel. Given any changes, they fire in parallel, and they all run through at the same time. If there are any differences from one to the other, that gets sorted out, as is being done right now. Since that second one did not get the first commit at the same time, that's going to flow right through. And you can see that our dependencies have changed a little bit, the rules about that. The same things don't need to pass. They can go all the way through. And then up until to version bumping, now we only bump the version if the change or resource passed through all the clusters. And that continues to go. And then we've added some convenience of grouping them so that you don't have to look at the whole thing all at once, because this could get quite big depending on what you're up to with your data. And that's building clusters. So sort of in conclusion, we know it's a good idea to give microservices their own data, but we know that there's a bit of overhead in doing that. But if you get creative and really like attack automation, you can get rid of a lot of that overhead. And a lot of it has to do with treating the configuration and the provisioning stuff that you have just like your code. It's the same tools, same workflows, and it works great for these things too. Use pipelines for operational tasks. For anything that needs to happen more than once or in more than one place, it's a great way to do it. Our last production change, we probably fired off 6 pipelines and made no manual changes along the way. That instills a lot of confidence in your changes, especially if you use them to test all the way through your environments. To consider creating templates and to actually generate pipelines for reuse. That means that other teams that need the same thing can use those and make small changes to them, and that you have a lot more consistency in everything that you do, which means more confidence. And that's what I had to show. I think we've got a couple minutes. We started a couple minutes early, so if there are questions, it'd be a good time.
This is tangential, but did you use any HCSC links in your REST APIs?
We have our mobile apps use HCSC links, and we're looking into starting to use it for the other ones that, especially where services want to refer to resources that other services have. Yeah, it's a very, very cool way to do it. Yeah. Any others? No?
How are data synchronized into your source data?
Yeah, that could probably be another whole talk, but there's a layer there where we had, this guy. That's a bit of a data pipeline. So we do have, and we're using Spring integration flows to bring that data forward, and using a very similar approach to deploying and building those things. And each API kind of has its own loader. So we have our source data as much as possible in like a canonical model that's shared throughout the enterprise. So what we try to do is get that data into the canonical model, and then the API teams from there can do the transformation into their application model. Since each one might have a different model depending on kind of their access patterns, that step is handled there. So we also have like a framework and some templates to make it easy for the development teams to do that. That's a big part of doing that too, is to make loading the data very easy. If you're going to load it in a lot of places with subtle changes, that you don't want to spend a whole lot of time on it. Yeah.
Did you guys have the challenges with CQRS and the eventual consistency, where some of the theories may depend on data real time?
Yeah, I mean, with the integration flow coming out, data comes very quickly, very near real time. Since we're not doing any writes at these APIs, we're spared a lot of headache of synchronizing things. Typically, the latency of the data getting into Geode has been totally acceptable. But we have some use cases like that where continuous queries are going to come into play for sure. Any others? Okay. Thank you, guys.